Welcome to Video 5 for this unit on expressions, equations, and inequalities. In this video, we're going to focus on writing equivalent expressions. We can use rectangles to organize the work of multiplying expressions. For example, the product 3/2 times the quantity 6y minus 2x minus 8 can be found by drawing three rectangles, with the factor 3/2 on one side and the three terms inside the parentheses on the other side. Remember, we can rewrite subtraction as adding the opposite. We multiply 3/2 by each term across the top. Then we reassemble the parts to get the overall product. We can also rewrite adding a negative as subtracting a positive. In this example, we expanded the expression, which means we used the distributive property to rewrite a product as a sum or a difference. So these expressions are equivalent. We can also use the distributive property in the other direction to factor an expression. The terms of the product go inside the rectangles. We look at the expressions and think about a factor they have in common. 12x and -8 each have a factor of 4. To find the other factors, we ask ourselves, 4 times what is 12x? 4 times what is -8? So 12x minus 8 is equivalent to 4 times the quantity 3x minus 2. No matter what value we substitute for the variable, these expressions will be equal. Two expressions are definitely not equivalent if they have different values when we substitute the same number for the variable. For example, 2 times the quantity -3 plus x plus 8 and 2x plus 5 are not equivalent. We can tell this because when x is 1, the first expression equals 4. And the second expression equals 7. However, it's impossible to compare two expressions for all values. To know for sure that expressions are equivalent, we use properties of operations. For example, this expression is equivalent to 2x plus 2 because we can apply the distributive property the commutative property, and the associative property. Combining like terms is an application of the distributive property. For example, 2x plus 9x is equivalent to 11x. because both terms have the common factor x. And then we can add the 2 plus 9. Combining like terms often involves other properties as well. For example, because addition is commutative, we can swap the order of the middle two terms. Because addition is associative, we can group the terms into pairs that have the same variable. Then we apply the distributive property twice. Here is a similar expression with subtraction. We can't change order or grouping when subtracting, so we rewrite subtraction as adding the opposite. Now we can apply the same properties as before. Here are some common errors with writing equivalent expressions that we can try to avoid. 6x minus x is not equivalent to 6. It might be tempting to think that subtracting x makes the x disappear, but the expression is really saying take one group of x away from 6 groups of x. So 6x minus x is equivalent to 5x. 7 minus 2x is not equivalent to 5x. This expression tells us to double an unknown amount and subtract it from 7. This is not always the same as taking 5 copies of the unknown. 7 minus 2x is equivalent to negative 2x plus 7, because we can rewrite subtraction as adding a negative and then apply the commutative property. 7 minus 4 times the quantity x plus 2 is not equivalent to 3 times the quantity x plus 2. The expression tells us to subtract 4 copies of an amount from 7, not to take 7 minus 4 copies of the amount. This expression is equivalent to 7 minus 4x minus 8, because we can apply the distributive property to expand the expression. Thank you for watching video 5 of 5 for this unit on expressions, equations, and inequalities.